Hello. In this video we're going to be finding the area between two curves. And so here on the right I have some region S that is bounded between two curves, one I've called f of x and one I've called g of x, and then two vertical lines, x equals a and x equals b. And so note that f of x is always above g of x between a and b. F of x and g of x are continuous during this whole interval as well. Now, since we're finding area, what we learned in our previous chapter is that we can draw a series of rectangles, and here I've drawn 7 rectangles, all again with the same width. I kind of tried to find the midpoint on these curves, and if we added up the area of these rectangles, we would be getting a good estimate of the area of, or the area between the two shapes. And so right below that I have the equation for the area as a limit and a summation. And so it's the difference between the heights of these two curves, and then we do the summation from 1 to n, where n goes to infinity. So as I add, what it's saying is I add more and more and more rectangles, all the way up to infinitely many rectangles, we're going to get the exact area for this shape. Now, based on what we learned previously, instead of looking at just rectangles, we can do the antiderivative, or the integral of these two functions. And so the integral from a to b of f of x minus g of x dx will give us the area S that I've shaded over there sort of in yellow. And the blue shape underneath, or the blue shaded part, is the area under the curve g of x. And so what I kind of want to show you here is if we found the area under f of x and found the area under g of x, and then subtracted those two areas, we'd have the total area of our region S. And so that's what we're going to do. We can either subtract f of x and g of x first and then find the antiderivative and evaluate from a to b, or we can find the antiderivative of each and then evaluate from a to b on each, and then do our subtraction last. So let's look at an example. Here I'm looking at the curves y equals x squared plus 1 and y equals x, and we are bounded between x equals 0 and x equals 1. So notice the curves are continuous. Our x squared plus 1 is always larger over the course of this whole curve, larger than y equals x. And so we're capable of doing the integral from 0 to 1 of x squared plus 1 minus x dx. And if we evaluate this, we should be able to find the area between the two curves that makes this weird looking shape that we have here. So let's go ahead and do that. First I'll actually do the subtraction. So from 0 to 1, if I subtract x off of this, it's simply x squared minus x plus 1 dx. And then do the antiderivative, raise the power by 1, and then multiply by the reciprocal, minus raise the power by 1, multiply by the reciprocal, plus raise the power by 1, and multiply by the reciprocal, which is 1, and we will evaluate this from 0 to 1. So let's go ahead and do that. So we have 1/3 times 1 cubed minus 1/2 times 1 squared plus 1. And all of that will be subtracted by, and then we'll do 1/3 times 0 cubed minus 1/3 times 0 squared plus 0. So this everything in yellow here, we multiply by 0, we multiply by 0, and then we take 0 plus 0 plus 0, so it's basically a nothing burger. Over here in the green, 1 cubed times 1/3 is simply 1/3. 1 squared and then times 1/2, we get our minus 1/2, and then plus 1. So let's get our common denominator here, which will be a 6. So we have 2/6 minus 3/6, but adding 6/6. 2 minus 3 plus 6 gets us 5 out of 6. So the area here is 5/6 square units. Okay, so that's your crash course on how to find the area between curves. We are done.